Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faizal Hadi bin Zulkifli. So I'm from Group 4. So today I want to explain about the power generation source, which we choose the wind. So the wind turbines is the main part. So basically how it works is that the wind will flow through the propeller-like blades of the wind turbines, which will create the air pressure difference and lift and create a force that will lift and drag the blades. So the blades will spin around the rotor, which will spin the generator and creates the electricity. So for our case, these wind turbines will generate around 2 megawatts to 3 megawatts, and it will produce around 690 volts. Each of the wind turbines will produce around 690 volts. So this wind turbine, we chose to place it at near the ocean because it's the best place to place a wind turbine. It's because the wind is the strongest and the most consistent in a large area such as the ocean, and probably because when the heat of the sun hit the land and the water, the land will heat faster, so the wind from the sea will flow through to the ocean. So the wind will get the benefit from that. The wind turbine will get the benefit. So the country that use the most wind turbine is China, and second is the US. So we can say the wind turbine is quite special because it doesn't burn any fossil fuels, doesn't burn any coals, it doesn't release any unwanted chemicals, substance into the air and pollute the air. So it's very special, and it's also one of the cheapest power generation source in the market. So that's all for me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzahan bin Marjohan with the metric number DE220147. Now I will explain about the transmission stage for the grid system in Malaysia based on our single line diagram prototype that we have made. So once the electricity is generated, it will embark on a journey through the high voltage transmission line. This line are often operating at voltage like 132 kilovolt, 275 kilovolt, or 500 kilovolt, and actually it will be act as a highway for the electricity. And then they will transport the electricity across long distance from power plants to the key substation spread strategically across the country in Malaysia.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kazaril Afham bin Kamrul Zaman. My number matric is CE220112. So today I would like to explain about the substation in Malaysia. The substation in Malaysia owns by TNB, which is Tenaga Nasional Berhad. A substation in Malaysia is a crucial component of the power distribution system. It plays a key role in transmitting and distributing electrical energy from power plants to end user, and ensuring the electricity is delivered efficiently and safely. Substations are integral to maintaining the voltage level, managing power flow, and protecting the electrical infrastructure. So there are two types of substation, which is step-up substation and step-down substation. Step-up substation, these are located near power plants and are responsible for increasing the voltage of electricity generated, make it suitable for long-distance transmission. For the step-up transformer, from the power plant, it will produce 12 kV. So it will step up to 800 kV or 400 kV for extra high voltage for the long transmission line. or it will be 220 kilovolt or 132 kilovolt for high voltage for the medium transmission line. Step-down substation, these are situated closer to populated areas and industries. They reduce the voltage of the electricity for safe distribution to end user, such as residential and industrial. So, for the step-down transformer, from 220 kilovolt or 132 kilovolt, it will reduce to 33 kilovolt. It will transmit to another substation which is 11 kilovolt, and then it will reduce to 415 volt or for the industrial and 230 volt for the residential. So there's a 4 components in substation, which is transformer, switchgear, circuit breakers and bus bar. So the first one is transformer. Substation contains transformer to step up or step down the voltage as needed. Secondly, the switchgear. Switchgear are the device used to control, protect and isolate electrical equipment. They play a crucial role in ensuring the safety and reliability of the power supply. The third one is circuit breaker. They are the device that can interrupt the power flow of electrical current in case of a fault, preventing damage to the equipment and ensuring the safety of the system. The last one is bus bar. These are conductors that serve as a common connection between different components within the substation. So that's all for me. Thank you.
My name is Koyum, and now I will further explain on the residential part of the generation, transmission and distribution system. So the residential sector is the endpoint of a comprehensive electricity generation, transmission and distribution system. The distribution system consists of a local network of power lines that carry electricity to residential areas. So the transformers further lower the voltage before the power enters home, ensuring that it is safe and efficient use, which is around, in our case, is 240 volt. So the residential segment encompasses individual household and buildings, representing the final destination of the electricity flow. So right here, consumers access the power for lighting, appliances and other domestic needs. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi and to all. My name is Muhammad Hafiz bin Muhammad Masanafi and my matrix number is DE220175. So, for my part for this video presentation, I would like to explain a bit about the industrial section in single line diagram. First of all, we need to know what is single line diagram. So, single line diagram is a simplified representation of the distribution systems of electricity within the facility of industry. We should know the flow from generation to the consumer. As for my group, we use the wind turbine as to generate our electrical supply. So from the wind turbine, it will move to the generation station to generate the supply, of course, and it will move throughout the transmission line in a high voltage range. Why we use high voltage instead of low voltage is because we need to minimize the losses throughout the lines. And from the transmission line, it will move to substation, and the function of substation is to step down the high voltage just now to a range that is suitable to use throughout the industrial site. And from the substation, it will move to distribution systems online, which is the function is that to distribute the step down voltage just now from substation to the industrial section or industrial site, of course. And from there, from the distribution system and distribution line, we will move to switchgear and transformer on site. And the function for both switchgear and transformer on site is that to be used for further control and also to distribute the step down voltage just now to certain parts of the industrial section. And for your information, in Malaysia, usually we use about 440 volts for 3-phase system in industrial section. And for the machinery and equipment, we use about 400 volts between phases and 230 volts between each phases and neutral line. And for your information also, usually in Malaysia, for the large industries, they have their own substation in order to ensure that the supply is uninterrupted. I think that's all from me for this industrial section in single line diagram. Thank you.